Hello, one more formula to derive, again with help of this formula for the sum of n first positive natural numbers. And this one is easy. It's not at all so difficult as the one presented in the documents to lecture 4, which I hope you have read because it's really interesting stuff. This one you can actually try on your own. I will give you a hint and you can try to solve this problem on your own. If it's difficult, just watch the video. Let's start. Derivation of a formula, problem number 4, and here is its formulation. Derive the following formula for a natural positive n, and here is the formula. So you see what we are doing. 1 squared minus 2 squared plus 3 squared minus 4 squared, and so on and so on. So the squares of all the odd numbers are coming with plus in this formula, and the squares of all even numbers are coming with minus. And we have to prove that this sum is, why do I say sum if I have minus signs too? Well, minus something is the same as plus negative number, right? So it's still a sum. Why it is equal to this expression? I will prove it, but first I would like to tell you, for those of you who like this new sigma symbol, that you can also write the left-hand side of this formula in this way. So you sum again n elements, and each element looks like this. And what I actually did was take the last element here and replace n by k, and tell that k varies from 1, because this one describes this expression for k equal to 1, to n, because the last one, the last term, is with k equal to n. Okay, so how can we prove, how can we derive this formula? I promised to give you a hint, and the hint is the following. Use the formula for the difference of two squares. How does its formula look? Well, a to n a squared, of course, minus b squared, the difference of two squares, where a and b are just some numbers, doesn't matter what. It can be natural numbers, it can be any real numbers, is equal to the product of the difference and the sum. This is the formula for the difference of two squares. And so try to use this formula for each pair separately, and you will see what you will get. So think about it. Maybe you want to solve this problem yourself. If not, well, I'm here to help you. First, I apply this formula for the difference of two squares for a equal to 1 and b equal to 2. So what do I get? A minus b is 1 minus 2 is minus 1. Maybe I will write it down first. 1 minus 2 times 1 plus 2, right? This is the application of this formula for a equal to 1 and b equal to 2. Then I move to the second pair and I apply the same formula again, but this time with a equal to 3 and b equal to 4. Then I first get 3 minus 4, and in the second parenthesis 3 plus 4, right? Then I continue, so I will write plus, and the last one. Here in the last one, I will use the same formula for a equal to 2n minus 1 and b equal to 2n. So first I will get in the first parenthesis 2n minus 1 minus 2n, right? And in the second one, 2n minus 1 plus 2n. This is my left-hand side. And now, you see what is happening here. 1 minus 2 is minus 1. 3 minus 4 is minus 1. and so on and so on. And in the last one, 2n minus 2n is 0, so you also just get minus 1. So all these terms in my new left-hand side have a factor minus 1. So I can factor it out. So I factor out minus 1. You see, this is this minus 1 which is present in all the terms, and then I will get, what do I get? Now, the best thing is to look at the last one here, because this last one can give you a hint what kind of formula you can use for the previous ones. So what do you get? Do you get in the last parenthesis? 2n plus 2n is equal to 4n, and then I have minus 1. So this gives you a hint that you can write down all the previous terms in this parenthesis in the same way. So first I take this blue one, 1 plus 2, it is 3, right? I can write it as 4 times 1 minus 1. Right? So you see, I use this expression which I got here from the last parenthesis, 4n minus 1, and I apply it for the first element, for the first term, to 3. 3 is equal to 4 times 1 minus 1. Then I do the same with 3 plus 4, which is 7, and 7, it is equal to 4 times 2 minus 1. Right? And think about it, I could have written one more, which would make it very clear. So what is coming after this 3 squared minus 4 squared? The next one would be 5 squared minus 6 squared, right? And it would be 5 minus 6 times 5 plus 6. So it is again minus from the first parenthesis, and from the second one we get 11. And 11 is equal to 4 times 3, it is 12 minus 1. So I can write it here, 4 times 3 minus 1. And so on and so on and so on. So I write 3 dots, and the very last one will be 4n minus 1. And you see what has happened here, right? You see that I can gather together all the terms here which are 4 times something, right? So what I'm doing here, instead of minus 1 times the parenthesis, I can simply write minus before parenthesis. You know that is the same thing, right? And then I can factor out 4 from all these terms which have factor 4, and then I will get, from the first one I will get 1, from the first time, for the second time I will get 2, from the next one I will get 3, and so on and so on, and from the last one n. So this part is corresponding to all these terms above, which were marked with orange color. And what do I have more? I have minus 1, minus 1, minus 1, and so on and so on and so on. And how many minus 1s do I have? Well, as many as I have terms here. And so this is my first term, this is second one, and this is the one number n. So they are n terms, so they will be n times minus 1. So it means that I have simply here minus n. And now again, I use my formula from problem number 1, because in problem number 1, I derived the formula for the sum of all the natural numbers starting with 1, ending with n. So I get here minus 4 times n plus 1 divided by 2, right? And then I have to subtract n, but you see I have minus n, which will be plus n, right? It will be plus n, because minus is plus. So what I see here, that I have some cancellation. Here I will just get 2. And now I have to put together my my result here. So I see that I can factor out minus n, right? And then from the first term, which is 2 times n plus 1, I will get just 2 times n plus 1, right? And from the second one, I will get minus 1, because plus n, it is minus n times minus 1. Okay, so now we just simplify and hoping that I will get here. So here I get minus 1 times 2n plus 2, right? I multiply the entire parenthesis by 2, and then I subtract 1. And I see here that indeed 2 minus 1 is equal to plus 1. So I get my final answer exactly as expected. This is the number I expected. So now you see that in derivation of this formula we used basically 3 tricks. The first one was using this formula here for the difference of 2 squares. The second one was the idea of using the general description for the last element in our sum from the form which was given in the last one, which was already written in an abstract way, apply this abstract way of writing to the previous ones. And the last trick, the third one, was application of this formula from problem number 1. Maybe I will write it here clearly, that here we use problem number 1. So 3 tricks. I hope that you enjoyed this one. Thank you for watching. Bye bye.